hopefully everybody can hear the sound, otherwise they're getting everything set up so they can hear the video. This is a lesson in the Chapter 4 Geometry Study Guide. Starting on page 11. So the top of the page, this is my handwriting, section 4.2. It's technically starts right here. Prerequisite skill, write and use congruence of triangles. Now, congruent means exactly the same. Okay, so you could have two angles that have the same measure, two line segments that have the same length, but here we're going to be talking about triangles. Figures is another word for shapes, so triangles and squares and kite shapes and what have you. So congruent shapes have the same angles and the same sides. So basically they're the same size and the same shape. Or I should say the same shape and same size. Now, corresponding parts basically means that when you have triangles or rectangles or, you know, pentagons or whatever, that there's going to be certain corners that kind of match up when they're the same size and shape. So you can see in this diagram we have two triangles. Obviously corner A corresponds to corner F because those are the two right angles. Do you see? And corner B corresponds to corner G because those are the two angles that are kind of around the corner to the right from the right angle, and so on. So there are parts that kind of match up naturally, like this side right here is the longest side, the hypotenuse on the right triangle. Side CB would correspond to this one, that's the longest side, the hypotenuse on the other triangle, side GH. So that's what corresponding parts are. They're either the angles that are the same angle corner or the sides that are the same side, corresponding from one congruent shape to its pair. So corner A goes with corner F, right? So when we talk about congruence, we have a certain way of notation. That means a certain way we write it down. So if we name triangle ABC, see this symbol right here? It looks like this. It's got a squiggle kind of symbol on top called the tilde, and then it's sitting on top of an equal sign. That is called congruent. Congruent. And in order to say that two shapes are congruent, they're the same shape and size, we have to name them exactly in the corresponding order. So if we say angle A, angle B, angle C, over here angle A corresponds with corner F, so that would come first. Corner B corresponds with corner G, so that would come second, and then finally corner C corresponds with corner H, so that would come third. So the order in which you say these two things are congruent is important. The corresponding parts have to be laid out explicitly in this statement. It's called a congruence statement or a statement of congruence. So I know I already talked about this. Angle A corresponds with angle G. I'm sorry, angle F. Oops, looking at the wrong part. Angle B corresponds with angle G. Angle C corresponds with angle H. Corresponding sides AB corresponds with GF. BC corresponds with GH. And CA corresponds with FH. Okay, so we can apply this whole concept of congruence and corresponding parts with the next few examples. We have two quadrilaterals, two four-sided shapes. It seems to me that R and X are the same corner, S and Y are the same corner, Z and T would be the same corner, and Q and W would be the same angle measure if indeed these are congruent. And you can kind of see that they've laid this out in the definition. Here's your statement of congruence. Q and W match up because of the first two letters. are an X matchup because of the second two letters. These are all the corresponding parts. S and Y are corresponding angles, vertices, and T and Z are corresponding vertices. Now, this also works really well with the sides. So for example, if you wanted to figure out which side corresponds with QR, that would be WX. Or if you wanted to find which side corresponds with RS, that would be XY. You see? So this statement of congruence is handy in many ways because it helps us kind of line up what matches with what. Okay, now we want to find the value of x. And I see that right here in corner W we have 5x plus 5. So I see that angle W corresponds with, or is congruent to, angle Q. You can see they're the first two letters in the statement of congruence. So that means that the measure of angle W must be equal to the measure of angle Q. So since W is represented by 5x plus 5, that amount should be equal to 65, measure of angle Q. So all I have to do now is solve this out. For x. And there you go. The value of x is 12. That's part A. Part B is finding the value of y. Well, the only y that I see is right here on side WX. See that? Now, what does WX correspond to? What side is it in equal length with? Well, WX corresponds with side QR. Oh, well, since I know that these two shapes are congruent, I know that the side lengths of the corresponding parts are equal. So the length here, WX, must be equal to the length there, QR. So let's use their more specific names. Here's the algebraic expression for the length from W to X. We call it Y minus X. And then here they say that's 6 inches. We'll just say 6. Now, we can't solve this for anything because we have two unknowns, but the thing we did first was find the value of X, so we can use that to help us here. I'm going to take out the unknown value and put in the known value, 12. And now I can solve for Y. Now I have an equation, and I only have one variable. So I can solve for that pretty simply by adding 12 to both sides, and Y is 18. That's part B. Alright, on the next page, I'm looking at identifying all the corresponding pairs of things. So it seems to me that angle U is congruent to angle H, and it tells us to assume that these two shapes are congruent. So you see how H and U are a corresponding pair. Even though they haven't marked anything else in the diagram, we can just go from this, can't we? That means that angle F is congruent to angle S, and angle G is congruent to angle T, and the last one, because we already stated the third one, the last pair would be angle J is congruent to angle V, right? Okay. Now the side lengths, or the side correspondences here and congruences, would be that FG is equal in length to ST. Those are corresponding. And then I'm going to use the middle two, GH is equal to TU. The last two, HJ, is equal in length to UV because they are corresponding sides on a pair of congruent shapes. And then finally, I'm going to go with the outside ones. FJ must be equal in length to SV. Okay. Now, it doesn't actually say find X, but we certainly could, because corner G right here is exactly congruent to corner T. So I could say, based on the fact that I've already figured out, given this information right up here, that corner G and corner T are corresponding parts on two congruent shapes, therefore they have the same measure. So if I wanted to find X, I could certainly do that. Like so. Not quite sure why that direction wasn't there. I did the first part, I identified all the corresponding parts, that's this, based on the name. I just figured I'd go ahead and find X. All right. All right, now the next two pages, let's see here, are based on certain theorems. Next page is based on the third angles theorem that says that if any two angles, this pair right here, BE, is the first pair, and another pair of angles, for example, A and D as another pair, are congruent. If you have two pairs of congruent angles, then the third pair must also be congruent. So angles C and F would then also have to be a congruent pair. So here's a proof where we're going to have to incorporate that theorem as we go along somewhere. So this theorem says that FH and JH are congruent sides. They've been marked that way. FG is congruent with GJ. It says angle FHG is congruent to angle JHG, and they've been marked as such. And finally, angle FGH is congruent to angle JGH, and they've been marked as such. So if we want to prove that these two triangles are congruent, basically what we have to prove is that all three sides pairs are congruent, and then all three angle pairs are congruent. So I think I'm just going to start by stating the given information. That's where we usually start with a proof. Okay, so how do we prove the three sides? Well, we have these two that match and these two that match. So the third pair of sides that match would basically be this one, GH. Essentially, it's the same side, but it's shared by the two triangles. So can I say that side GH is congruent with itself? If I can, then I have all three corresponding sides that match. And that's good, because that's one of the things that we need to prove the two triangles are congruent, right? So the theorem that says that side GH would be congruent with itself is called the reflexive property, right? We talked about that back in chapter 3. And the reflexive property basically says that anything has to be congruent with itself. Now, we have all three sides that are congruent, all three side pairs, I should say. FH and JH, FG and JG, and GH and GH. Now we need all three pairs of angles to match. We have this pair up here, this pair down here, and now we have to figure out some way to show that this corner here is congruent to that corner there. So let's see. Well, there's a theorem at the top of the page, isn't there? It's called the third angles theorem. It says that if you have one pair and two pairs of corresponding angles, that the third pair must also be congruent. Hey, I believe that's our situation here. We have one pair, two pairs of corresponding angles and triangles, so therefore the last pair would have to be congruent. So I'm going to go ahead and say that angle HFG, that's this one, is congruent to angle HJG, that's that one, by the third angles theorem. So there you go. We actually have all three side pairs matching up and all three angle pairs matching up. So that's how we know that triangle FGH is congruent to triangle. Now be careful because the order matters. Corner F corresponds to corner J, so that would come first. Corner G corresponds with, well, itself, doesn't it? And corner H also corresponds with itself. So by the definition of congruent triangles, we are finished with that one. Okay, properties of triangles. The reflexive property says that any triangle would have to be congruent with itself. The symmetric property says that if a triangle is congruent to another one, you can state that in the reverse order, meaning that triangle DEF is congruent to triangle ABC. And then the transitive property of congruent triangles simply says that if you have triangle ABC congruent to triangle DEF and triangle DEF congruent to triangle JKL, then triangle ABC would have to be congruent to triangle JKL. So this proof actually incorporates a lot of different concepts that we've been working on in Chapter 3 and Chapter 4. So we'll just take it one step at a time. Given information, there's a lot of given information. It says that AC is the E is the midpoint of AC and BD. And what else do we know? From the diagram, it seems that they've already marked AB congruent to DC. So you can count that as your given. Even if it's not written out in words, if it's on the diagram, you can use it. I noticed that I have little arrows right here and here. That means that this side right here is parallel to that side. So I'm going to say that side AB is parallel to side DC. Wow, well that's a lot to work with. It's good when we are starting with a theorem or a proof that doesn't have a whole lot to start with. It sometimes is harder, but we've got a lot to go on. So how do we show that triangle ABE is congruent to triangle CDE? Well, if I want to prove that these two triangles are congruent, the first thing I would think of is that the angles, the corresponding angles, have to be congruent. So I might start with saying, hey, angle A and angle C, since they're obviously corresponding based on this statement, how do I prove that they're congruent? Well, I'm going to use the fact that AB and DC are parallel lines, and this line right here, segment AC, is our transversal. If that's true, then is there a relationship between angles A and C? Yes, there is. It's called the alternate interior angles theorem. So here's your two parallel lines. Here's your transversal. These are on the opposite sides of that transversal, and they would have to be congruent if those two lines indeed are parallel. And we know that because it was given. So I can say that the measure of angle A, or actually angles A, is congruent to angle C. Oh my goodness, I can't write today. There we go. Angle A is congruent to angle C because of the alternate interior angle theorem. Now I actually have another pair of angles that I want to prove. I want to prove that angle B is congruent to angle D, and that would actually be the same reason. Since these two lines are parallel, and there's a transversal line here running DB, then according to the same theorem, angle B and angle D would have to be congruent. So I don't have to list that twice. The reason for each of these statements is the same. All right. And then finally, I want to state that somehow that angle E is congruent to angle E. But there are actually two different angle E's. This one's over here, and this one's over here. So one I'm going to call angle AEB, and the other one I'm going to call angle CED. So angle AEB is congruent to angle CED, and the reason for that would be because these two lines are crossing each other at that intersection point, and these two angles that I want to state are congruent are exactly across from one another. That theorem would be the vertical angle theorem. Or more formally, the vertical angle congruence theorem. Okay, so we're almost there. We know that we have three pairs of congruent corresponding angles. So we're done with the angles part. Now the next part is just showing that corresponding sides match. So for example, I want to show that side excuse me, AB is equal in measure to side CD, but you know what? They've already been stated in the given. They've already been marked as congruent. So, okay, one pair down, two more to go. So how about this one? What if I want to state that BE is congruent to DE? So BE and DE would be these two. Well, since I know that E is exactly the midpoint between B and D, that was stated right here in our given, then I know that because of that whole concept of what a midpoint is, that this length right here on this side and that length right there on that side would have to be the same. So I can make the statement that BE is indeed congruent to ED because E is the midpoint, because of the definition of a midpoint. And then finally, the third pair of sides that need to be shown congruent would be AE and CE. So that would be AE and CE. And we have basically the same theorem, right? E is the midpoint between A and C. So we can say that side AE must be congruent with EC for the same reason. So I simply added that statement onto the side, on the statement side for number 4, because the reason was the same. Definition of the midpoint, because E is the midpoint. So we finally have 3 pairs of angles that match and 3 pairs of sides that match. They're all congruent pairs. And so we can finally say that triangle ABE is congruent to triangle CDE by the definition of congruent triangles. And then on the last page here, I'm going to just do part of it, not all of it. So let's see. Number 9. Are these 2 triangles congruent? Well, do I have any side lengths that match up? Does this side match that one? No. Does this side match anything over there? No. Does this side match? No. So from one triangle to the other, there's no pairs of sides that have the same length. So even though the angles all match up with the other angles, this would be 2 triangles that are not congruent. Angles match, but there are no side pairs that match. And we would need 3 of them. On number 10, I have this angle that's 90 degrees, which means that this one would also have to be 90, so that's 1 pair of angles. I have angle X marked congruent with angle Z, and then by the third angles theorem, this angle over here would have to be congruent with this angle over here. So we have 3 pairs of angles that match. Do we have 3 pairs of sides that match? Well, obviously this side matches with that side, that's 1 pair of sides. This side here matches with this side here, that's a 2nd pair of sides. And then the third pair of sides would actually be this side and itself, YW and YW. So yeah, a side always matches in length with itself. So that's essentially our third pair. So yeah, we've got 3 pairs of angles that match, we've got 3 pairs of sides that match. So yes, indeed, these 2 triangles are congruent. So if I stated that triangle XYW is congruent to triangle, make sure we have the right order. X matches up with what? Z. Y matches up with itself. And W matches up with itself. For the same reasons that I talked about here, we could use over here. We could use our third angle theorem to prove that this angle right here is congruent to that angle there, and we could use the reflexive property to prove that GE was congruent with itself. So for those same reasons, I could say that triangle DGE is congruent to triangle. D matches with F. G would match with E, and then E would match with G. So the statement on this one is a little confusing, but if you think about it, DG does indeed match up with FE, right? Because those 2 sides are congruent, so those 2 would match. And GE would match with itself. And then DE, the outside letters, would be this side, and the outside letters here would be FG. So by checking it that way, it works. So for number 13, if we want to figure out the values of X and Y, we can just kind of start lining stuff up. Lining stuff up in terms of angles that are congruent and corresponding. So for example, corner C, if I look up here in the definition of congruence, corner C is corresponding and congruent to corner F. So that's this one. Well, I don't have an angle down here, so that's not really helpful. Is there anything else I know? Well, I know that corner A is corresponding to corner D according to the definition of congruence here. Statement of congruence. So, okay, if these two are congruent, then I can say that they're equal. And so I can set up an equation where 5x plus 2 is equal to 87 degrees. So if I subtract on both sides, then x equals 17. Okay. Now, how do I find this corner here? Well, there's a couple ways to do it. One would be that if I know on this triangle that I've got 3 corners, what would this corner be? Well, corner B corresponds with corner E, right? So if this is 42 degrees, that's 42 degrees, right? So I can use a couple different ways of thinking about this. I know on this triangle that all 3 angles will have to add up to 180 degrees. So corner C plus corner A plus corner B. If you add up all 3 of the interior angles of a triangle, they add up to 180. Now there's other ways of going about this. You could figure out what this angle is over here by substituting in x and then subtracting from 180 and making a simpler equation there. I think this is equally good a method. So I'm going to consolidate over here by adding the like terms and then do some subtracting. And dividing. And y is 37. And then the last example for 4.2 is corner H matches with corner T. So this corner and this corner match. So I can set up an equation here to find the value of A by saying that 6A minus 3, this corner, must be equal in measure to that corner if these 2 triangles are congruent and those 2 corners are corresponding. So I'll add 3 on both sides. Divide by 6, and A equals 9. Let's see. Does K match up with R? No. You can see here in the definition that corner K matches up with corner S. So this corner right here would actually match up with that one. But also according to the definition of congruence here, J matches up with R. So corner J up here matches up with corner R over here. So that must mean that this angle right here is 83 degrees. So just like in example number 13 up here, I can use my interior angles theorem that says that if you add up all 3 angles inside a triangle, they add up to 180. 7b minus 10, that's the first angle, plus 51, that's the second angle, plus 83, that's the third angle. All 3 of those measures should give you a sum of 180. Alright, so I'm just going to put these 3 parts together. So if I add 83 and 51, and negative 10, I get positive 124. So I can find my value of B by simply solving this equation out. and b equals 8.